أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. We thank Allah, our Creator, the one who sent Prophet Muhammad sallallahu alaihi wasallam to be a guide for us. Allah subhanahu wa ta'ala, the one who taught men by pen. We pray Allah increase us in knowledge. This is lesson 2 of the topic we started, chlorine and its compound, for 6th week. In the series of our topics that we shall discuss in this third term at the Chm2 Model College, Ibadan, Oyo State, Nigeria, as presented by Master Ojekunle Ridwanullah and Master Abdulateef Mansour. So the lesson 2 continues from where we stopped the other time. We have looked at the discovery of chlorine, its laboratory preparation, its electronic configuration, its industrial operation and physical properties, chemical properties, how it can be tested for, its uses. Here, this is one of the compounds of chlorine, hydrogen chloride. This hydrogen chloride, in its pure form, it was first prepared in 1772 by a scientist known as Priestley. The scientist named it marine gas. Why? Because it was made from sea salt as at that time. It exists as a gas at STP, standard temperature and pressure, and forms hydrochloric acid when dissolved in water. This gas, how can it be prepared in the laboratory? Hydrogen chloride is prepared by the action of hot concentrated tetrasulfate acid on any soluble chloride, be it sodium chloride, calcium chloride, and the likes. As you can see in this equation, NaCl plus H2SO4 giving us NaHSO4 plus HCl. When the temperature is low, you have sodium hydrogen tetraosulfate 6 being formed. Now, increasing the temperature, that is at high temperature, we are going to have NaCl combining with NaHSO4, then we have more of the hydrogen chloride gas formed, as you can see in these two equations here. Moving forward, this particular diagram shows the setup for the laboratory preparation of the hydrogen chloride. We have the sulfuric acid, that is concentrated tetrasulfate inside this funnel, and we have the conical flask containing the sodium chloride. When we release the acid from the funnel into the conical flask, we're going to have evolution of gas. So the gas will pass through the delivery tube, and we have at the middle here concentrated sulfuric acid, another one. The essence of it there is to dry the gas that is evolved from the conical flask. Then when it is dried, it is now stored or collected by what? By upward displacement of it, that is downward delivery. So we are going to have hydrogen chloride gas there. We also have the equation below as we have shown before. Sulfuric acid plus sodium chloride, sodium hydrogen sulfate plus hydrogen chloride. So the sodium hydrogen tetrasulfate 6, when it combines at high temperature with more of the NaCl, then we have more of the HCl, that is the hydrogen chloride gas formed. How can we prepare this in the industry on a large scale? That takes us to industrial preparation of hydrogen chloride. This hydrogen chloride, one of the compounds of chlorine, is made in large amounts by direct combination of hydrogen and chlorine gases. Where do we form them? The hydrogen and the chlorine gases that have already been formed from the electrolysis of brine. We know that we can prepare hydrogen by process of electrolysis. When we talk about it in industrial preparation, we can also prepare chlorine from electrolysis when we talk about its industrial preparation. Now, these two gases, when they are now combined together, they can give us hydrogen chloride gas by simple direct combination. So the gas produced can then be dissolved in water to form hydrochloric acid. That means if we have produced our hydrogen chloride gas, We can form our hydrochloric acid from it by simply dissolving it inside what? Inside water. Now, physical properties of hydrogen chloride gas. Number one, hydrogen chloride is very soluble in water. It forms hydrochloric acid. When it dissolves in water, it's about 1.25 times denser than air. Pure hydrogen chloride is a colorless gas with a sharp, irritating smell. It turns damp blue litmus paper red. That's hydrogen chloride gas. Does not support combustion. Even when something is burning, it even extinguishes burning splinter. Yes, it extinguishes burning splinter. Unlike oxygen or hydrogen that they glow burning splinter. So oxygen makes burning splinter to burn the more. Even hydrogen does the same. So even hydrogen gives a pop sound with it, but hydrogen chloride gas doesn't do that. Chlorine also makes burning to continue. Hydrogen chloride doesn't do that. It extinguishes a burning splinter. What are the chemical properties of hydrogen chloride gas? Hydrogen chloride gas forms a dense white fumes of ammonium chloride. It forms a dense white film of ammonium chloride with ammonia. It reacts with metals to form the respective chloride and hydrogen gas. Usually, the lower chloride is formed if the metal can form two chloride. What does it mean? If we have, for instance, iron, like we have mentioned in lesson 1, like iron is a transition metal, it can form different chlorides, the iron 2 chloride and the iron 3 chloride. When you have this particular hydrogen chloride gas reacting with metals, well, it forms the lower chloride here, not the what? Not the higher chloride. It forms the lower chloride, not the higher chloride. Unlike when chlorine reacts with this metal, chlorine makes it to form what? To form a higher chloride. But hydrogen chloride reacting with metal that can form more than 2 chlorides, usually the lower chloride is formed, which is iron 2. Moving forward, what are the properties of this hydrochloric acid that is formed by the dissolution of hydrogen chloride gas in water? Number one, we have its concentrated form and we have its dilute form. If it happens that the concentrated form of this hydrochloric acid is boiled, when you boil it, the concentrated form of it releases fumes of hydrogen chloride gas, while a dilute form of the acid boils and releases water or vapor. Now, when the boiling process gets to a stage for concentrated acid, what will happen is that the concentrated acid, that is the former, becomes more dilute because hydrogen chloride gas will be released from it, while the latter, that is the dilute acid that you are boiling, will become more concentrated because water will be going out from it. It will now reach a point when a constant boiling mixture or a azeotropic mixture will be formed, such a way that that kind of mixture contains about 20.24% hydrochloric acid. So when you have this azeotropic mixture that is formed, there is no further boiling or no further boiling process you do that will affect the concentration of such a mixture again. So here, when the azeotropic mixture is formed, any further heating will not affect its concentration. It will just remain like that. So this property for behavior of hydrochloric acid, will properly taken note that okay, when you have the concentrated form of it, when you boil it, what will be released is what? Is hydrogen chloride gas. When you boil the dilute form of it, what will be releasing is water vapor to make the dilute form to be more concentrated. So when you get to a point, no gas will be released. Maybe be it water vapor, be it. So at that point in time, you have about 20.24% of the hydrochloric acid present in the solution. Number two property of this hydrochloric acid is that the acid reacts with metals, it reacts with bases, it can also react with triazocarbonates as follows. When it reacts with acid, it releases hydrogen gas. When the acid reacts with metal, it releases hydrogen gas, and we have the chloride of the metal being formed. Like zinc reacting with HCl, giving us zinc chloride and H2 as we have in 2A here. 2B, we have the base, zinc oxide, reacting with the acid, hydrochloric acid, giving us zinc chloride, and we have the water or the steam being released. Then we have sodium triisocarbonate 4 reacting with hydrochloric acid. What do you have as a product? You have sodium chloride, you have water, and you have CO2 being released as the gas. If HCl act as a precipitating agent, HCl, that is hydrochloric acid or the dissolved hydrogen chloride gas in water, when it acts as a precipitating agent, how does it behave? It can react when hydrochloric acid is added to silver triisonitrate 5 or lead 2 triisonitrate 5 solution. A white precipitate of silver or lead 2 chloride is formed. This equation here is only showing for the silver nitrate and HCl. We can also have it for lead nitrate and HCl. For the reaction of lead nitrate and HCl, we are going to have lead 2 chloride being formed, and you are going to have HNO3 being released as well. So meaning that we have AgNO3 is soluble, HCl is soluble, AgCl it is insoluble, forming a precipitate. Then HNO3 is also soluble. So that means I've been able to precipitate out a particular substance there. That is why if you want to precipitate the chloride, the silver, you can use HCl as a precipitation agent. Then it should be noted that concentrated hydrochloric acid can be oxidized by strong oxidizing agents to release chlorine. This reaction is telling us that strong oxidizing agents can make chlorine to be released from HCl. HCl is an organic acid, right? This kind of reaction doesn't take place for H2SO4, the same organic acid as HCl. The reason is that concentrated hydrochloric acid is easily oxidized by strong oxidizing agents such as potassium tetrahydromanganate 7 to liberate chlorine. You always see that when we are talking about oxidation, we acidify. This is why hydrochloric acid is never used for acidifying solutions of oxidizing agents. Instead, we use tetraisosulfate 6 acid, because if you use HCl, the oxidizing agent itself will make chlorine to be released. So that means the aim of using that has been defeated. But if H2SO4 is used, nothing will happen to it. It will not get oxidized by the oxidizing agent. But HCl can be easily oxidized, and you are going to have chlorine being released. How do you test for hydrogen chloride? Hydrogen chloride can be tested for if you have an unknown gas. It forms a dense white film with ammonia, and that unknown gas will tell you that it is actually hydrogen chloride. How does it take place? If an unknown gas that is colorless, has an irritating smell, film in moist air, and turns blue litmus paper red, so you may suspect hydrogen chloride. But if you want to actually confirm this test, you can use 2 basic tests for it, with ammonia or with silver triisonitrate 5. If it is with ammonia, as we have here in the number 1 here, you place a glass rod already dipped with ammonia solution at the mouth of a gas jar containing the unknown gas. Now, if the gas is hydrogen chloride, the gas you don't know if it is hydrogen chloride, you are going to have a dense white films composed of suspended particles of ammonium chloride being produced. That is using ammonia to test for the unknown gas if it is hydrogen chloride. For the second one, with silver triisonitrate 5, add a few drops of silver triisonitrate 5 solution to a gas jar containing the unknown gas. Then shake. If the gas is hydrogen chloride, a white precipitate of silver chloride will be formed. Silver chloride will be formed. When silver chloride is formed, so that means the gas you don't know that is suspended in the solution. So is what is hydrogen chloride gas. What do you use hydrogen chloride or hydrochloric acid for? Number 1, it is used in chlorine synthesis for plastic production. Hydrogen chloride gas is used in the synthesis of chlorine for plastic production. Number 2, it is used in the manufacture of textiles and dyes. Yes, you should know that this hydrochloric acid that is formed when you dissolve hydrogen chloride inside water is used in the manufacture of gelatin and glue from the tendons of animals, and in the production of glucose from starch. So that is that. Number 3, hydrochloric acid is used to remove oxides from metals before electroplating. Hydrochloric acid is used to remove oxides from metal before electroplating, because if you want to plate a lower metal with a higher metal that cannot get rust easily, so you need to remove any form of oxide that are present there before you actually plate it, so that the plating would last for a long time as it's supposed to be. Number 4, hydrochloric acid is used for testing, for analysis and preparation of other compounds in the laboratory. So far we have been able to talk about hydrogen chloride. This is one of the important compounds of chlorine. We have looked at its discovery, how it was formed by earlier scientists, how it can also be prepared in the laboratory nowadays, its industrial preparation. We have been able to look at its physical properties. We have been able to look at its chemical properties. We have been able to look at the series of reactions it can undergo. Then we have been able to look at its uses. How do you test for it? We have been able to look at it, inshallah. So week 7 is when we shall continue with the other broader aspect of a chlorine and its compound, where we shall be talking about the chlorides, and we also compare some of the properties of the halogen family. I pray Allah subhanahu wa ta'ala grant us the understanding of what we have discussed so far. May Allah bless our knowledge, may Allah bless our school, may Allah bless our teachers, bless our parents, make us inmates of Al-Jannah, pass us well in all our exams, internal and external exams. Birahmatika ya arhamar rahimin. I remain your tutor, Master Adekunle Ridwan Babatunde. Till we meet again, Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.